Welcome to CSC 106 and Introduction to Computers and Programming. I'm your instructor, Larry Schoeneman, and we're going to talk about some basics here. And in the next videos, we will talk about other things. We're going to discuss introduction, hardware and software, how computers store data, how a program works, and using Python. Each of these videos will be followed by a coding video. There's also an introductory video to the class discussing the syllabus. So, computers can be programmed and are designed to do any job that a program tells them to. A program is a set of instructions that a computer follows to perform a task. This is commonly referred to as software. A programmer is a person who can design, create, and test computer programs, also known as a software developer or software engineer. You will hopefully continue down this path and learn to program in not only Python, but other languages as well. Hardware and software are the physical devices that make up a computer. A computer is a system composed of several components that all work together. Typical major components include the central processing unit or CPU, main memory, secondary storage devices like hard drives, and input and output devices like printers, screens, keyboards, that sort of thing. The CPU is called the central processing unit. It's the part of the computer that actually runs programs. It's the computer. It's the most important component, and without it, you can't run software. It used to be used, but now they're tiny, and CPUs are now on small chips called microprocessors. And these are the heart of any modern computer system. Main memory is where the computer stores a program while running, and data also used by the program. It's known as random access memory. The reason it's called that is because it can be quickly accessed, but it's volatile. When the power goes off, it gets lost. Secondary storage can hold data for long periods of time. Programs normally stored here and loaded the main memory when needed. And there are types. Disk drives are magnetic disks. Solid state drives are faster, and then tape, which is really slow. Input devices. Data the computer collects from people. We've got keyboards, mouse, touch screen, scanner, pens. Disk drives can even be considered input devices because they load programs into the main memory. As we go on, you'll see there are other input devices, electric signals, that sort of thing. Output devices produced by the computer for other people. Text, image, audios, or bit streams. The output device formats and presents output. Video displays, printers, USB drives, disk drives. The network, the internet can be considered output devices. Anything that can receive data. Software is everything the computer does controlled by software. Application software and system software. Application software is programs that make computers useful. Word processing, email, games, and web browsers, for example. Thousands of categories here. Additionally, system software is a program that control and manage basic operations of a computer. An operating system controls the operation of the hardware, for example. All computers are stored in ones and zeros. A byte is just enough memory to store a letter or small number, and it's divided into 8 bits. A bit is an electrical component that can hold positive or negative charges like on or off. The on or off bit of a byte represent data stored in the byte. So 8 bits can have up to 255 values because when you string them together, you have 255 possibilities for each of those 8 bits. Okay. Then from there, we have how we store numbers. A bit represents 0 and 1. Computers use binary numbers. The position of digit j is assigned the value to j minus 1. So, for example, 101 is 2 to the j is the minus 1, so it'd be 0 to the first, which would be 1, plus, or 1 to the first, which is 1, or 1 to the 0th, which is 1, 0 to the second to the first, which is 0, and 1 to the second, which is 4, so the total would be 5. Byte size limits are 0 and 255. 0 means all bits are off. To store larger numbers, what we do is we use several bytes to represent larger numbers. 2 bytes can represent 65,536 possibilities, and so on. Okay. From here, storing characters. Data stored in a computer must be stored as binary numbers. Characters are converted to numeric code. Numeric code is stored in memory. Most important coding scheme is ASCII. It's limited to 128 characters, so it is limited. A new scheme called Unicode doubles the space, so it can store thousands of characters like Chinese, Japanese, Hebrew, etc. To store negative numbers and real numbers, computers use binary numbering and encoding schemes. Negative numbers use what is called 2's complement, where they flip the values and add 1. Real numbers use a very complex encoding notation for floating points. Other types of data. Digital describes any device that stores data. Digital images are composed of pixels. To store images, each pixel is converted to a binary number representing the pixel's color. Digital music is composed of sections called samples, and to store music, each sample is converted to a binary number. And those together can be reassembled to make pictures or music. How does the CPU work? The CPU is designed to perform simple operations on pieces of data. For example, reading data, adding and subtracting, multiplying and dividing. It understands instruction written in machine language and includes its instruction set. Each brand of CPU has its own instruction set. To carry out meaningful calculations, the CPU must be programmed. Program must be copied from secondary memory to RAM every time the CPU executes it. The CPU executes the program in a cycle. Fetch reads the next instruction. Decode, the CPU decodes fetched instructions to determine which operations, and execute performs the operation. Okay? So here's an example. 1, fetch the next instruction, and that's the bytes. 2, we're going to decode the instruction, turning this number into something like add register 1 and register 2. And then we're going to execute the instruction, perform the operation. So it goes from main memory to CPU. So machine language is impractical for people because you can't really read it. Assembly language uses short words like add instead of 101001. It's easier to work with. Assembly language translates assembly language to machine language for execution. But it's really hard to work with assembly language too. So on top of that, what we've done is we've built what are called higher level languages. Okay. They are not close to the machine, and they allow simple creation of programs, both complex and simple. You don't need the details of the CPU, and they're much more English-like and easier to understand. They represent concepts, not bytes. Every language has keywords, operators, and syntax. Keywords are predefined words used to write programs in a high-level language. Each keyword has a specific meaning. Operators perform operations on data. For example, math operators perform simple arithmetic, x plus y. Syntax is a set of rules to be followed when writing a program. It's how to write a correct statement. A statement is an individual instruction used in a high-level language, like print your name here. Okay, that's the basics of how you make it. A compiler and interpreter. Programs written in high-level language must be translated into machine language to be executed. A compiler translates high-level language programs into separate machine language programs, and they can be executed at any time. So, for example, this turns it's like a translator. You have a book in English; it's translated to Spanish. Okay, then we have what's called an interpreter. This is more like a real-life interpreter. It does it on the fly. You say a sentence, it converts it to a runnable machine language. Python is an interpreter, and it determines one instruction at a time and doesn't generate its own machine language program. Source code are statements written by a programmer, and syntax errors are things that are incorrect grammar that prevents code from being translated. So here's an example. High-level program. Hello, Earthlings. And the interpreter translated on the fly to machine language instruction, and it's run in the CPU. And this is repeated for every high-level instruction. It is less efficient than a compiler, but it does have advantages, and it's easier and more portable. Python must be installed and configured prior to use. One of the items installed is the Python interpreter. It can be used in 2 modes: interactive mode, where you enter statements on the keyboard, or script mode, where you build a file. We will also be using code spaces in development to make it easier. When you start Python in interactive mode, you'll see a prompt. This indicates the interpreter is waiting for Python statements to be typed. Prompts reappear after previous statements is executed. Error messages are displayed if you incorrectly type a statement. It's a good way to learn new parts of Python, and we'll go through it in the demo video. Okay. Programs and running in script mode, statements are entered into a file and are not. When you do interactive, it's not saved. To have a program, use a script mode. It collects a set of Python statements, and you run it by typing Python file name at the operating system command line. And we'll also show how to do that with code spaces. Okay. The idle programming language, integrated development programming, is a single program that provides tools to write and execute test program. We're not going to use the built-in Python one. We're going to use code spaces. It's much easier to use. Okay, and much preferable. So we're going to show you how to use that instead. Okay. So we've covered main hardware components, types of software, how data is stored in the computer, basic CPU instructions, the fetch, decode, execution cycle, complex languages, and installing Python. Now in our next video, we will demonstrate how to install Python, code spaces, and get started running our very first programs in a high-level language. We'll also talk more about data structures and algorithms and how data is organized in a complete program. Talk to you later.